In the previous problem, we saw that the period for a circular motion of a particle in a magnetic field was given by 2 pi m over qb, which means that the frequency, little f, which equals 1 over t, then would equal qb over 2 pi m. And if that is the case, and we look at the ratio of q over m, so if I isolate q over m, then I get q over m equals 2 pi times the frequency divided by b, which means that I can get the reason why we do the mass over charge ratio is because that is a technique used for cyclotrons and accelerating devices a lot. So if we solve for the magnetic field in this case, we're going to get 2 pi f times m over q. And if we plug in these values, we get 2 pi. The frequency is given as 12 megahertz. So that's 12 times 10 to the 6th per second times the mass of twice the proton, we're told, so that is twice 1.67 times 10 to the negative 27th kilogram all over the charge, which is 1.6 times 10 to the negative 19th coulomb. Excuse me. So this gives us a magnetic field of about 1.57 Teslas. And now we've also seen that the radius of, we saw from F equals mv squared over r, that qvb equaled mv squared over r, which means that r can equal or better yet, v equals r q b over m. And if we plug these numbers in, we get r, which is 0.53 meters. That's the radius. The charge of a proton is 1.6 10 to the minus 19 coulombs. Magnetic field we just found was 1.57 Teslas. And the mass again is twice that of a proton. And if we do this, we get a speed of 3.99 times 10 to the 7th meters per second. And so the kinetic energy is 1/2 the mass, which is twice 1.67 10 to the minus 27th kilogram, times the speed, which is 3.99 times 10 to the 7th meters per second squared, which gives us 2.7 times 10 to the negative 12 joules.